Hello, welcome. Let's try to solve another Leetcode problem, 1008. Construct binary search tree from preorder traversal. So we are giving the preorder traversal, but this is just an array. And we're going to return the binary search tree. And we should know that it is just a binary search tree. It is not balanced binary search tree. Yeah. So for example, we are giving this kind of a preorder traversal. So for example, the node is 8, the left side is 5, right side is 10, and for the node 5, the left is 1 and the right is 7. And for node 10, the right side is 12. So for such kind of a preorder traversal, we're going to turn this kind of a preorder traversal to a binary search tree. As we can see the example, this is going to be a binary search tree. Like 8, the left side 5 is less than 8, the right side 10 is going to be more than 8. And we should also know that all the values of preorder are unique. Yeah, if it is unique, basically it is better for us to use the preorder traversal, and better for us to use the binary search tree idea. So for us, we're gonna start DFS. So the DFS is gonna be, I'm gonna put the preorder inside the nums because I'm gonna call the DFS with the preorder array. Yeah, now let's just check the property of the preorder array. So for the preorder array, there are going to be some properties. So the first node is going to be 8. Yeah, so this node can always be the root node. If you don't believe it, let's just check that. So the first node 8 gonna always be the root node. So this is gonna be a root node, as we can see it from here. So this is gonna be the root node. And then, what about the second node? We don't know it yet, but it will continue the second node to the third node, the fourth node. Yeah. So from node 5 to node 7, I mean 517, it must belong to the left subtree. And from 10 to 12, it must belong to the right subtree. So according to this type of property, definitely we can solve the problem. But how can we check that 5 to 7 is going to belong to the left subtree, and 10 to 12 is going to belong to the right subtree? So if it is like that, if there's some values, maybe it's going to be 14 or something, it always be at the right side. So this is just the preorder traversal. This is the property of the preorder traversal actually. So for us, first of all, we're going to check the root node, and then we're going to compare the values with this root node. If we find a value, we just loop from the left to right. If we find a value that is bigger than this value 7 and smaller than this value 10, so this means we find where gonna be the split for the left and right subtree. So the split is gonna be at this 10. So before 10, 5 to 7 is gonna be at the left side. So after 10 and 12, it's gonna be at the right side. And we're gonna recursively call this kind of a function, and finally we're going to get the final result. Now let's just use this idea to solve the problem. So we're going to check the nums. So if there's nothing inside of the nums, basically we're going to return a none. This means it's going to be the leaves. So otherwise, I'm going to check the first. I'm going to check the root node first. So the root node is going to be a tree node, and inside it's going to be nums 0. So this means the nums exist. It's going to at least have one value. Now I'm going to check the I'm going to check the index first. So I'm going to prepare an index. I'm going to prepare a function. So this function is going to be I'm going to call it like a check. So this check function basically to check where going to be the position. So for example, for this position, it's going to be between 7 and 10. I'm going to have a split. Now I'm going to check the node.left. I'm going to call the DFS. So it's going to be nums from 1. At 0 going to be the root node. So it means from 1 to I. And node.right going to be equal to DFS from nums I to everything at the right side. Finally, I just need to return the node, which is going to be the root node. Now we just need to finish the check function. Check function will not be so difficult. And inside, I'm gonna prepare maybe, let me just prepare the nums. It's gonna be the same as the nums from here. So I'm going to prepare a final result. So I'm going to prepare a variable n. It's going to be the length of the nums. So the result is going to be equal to n. So if we didn't find a position, so definitely it's going to be n. Now I will have a check first. So if nums 0 equal to the minimum of nums, this means it's going to be the this means for the root node it's going to be the smallest value. So basically at the right side it's going to always be bigger than this value. So this means at the left side it's going to be nothing, at the right side it's going to always be bigger than this value. So if we meet this kind of condition, basically we're going to return a 1. If we return a 1, basically means 1 to 1. It means from the left side there's going to be nothing. Now we're going to use a for loop to check. So for the for loop, it's going to be from 1 to n minus 1. So if nums I less than or equal to nums less, because it is always unique, nums 0 and less than nums I plus 1, basically I can return I plus 1. It means I found the position. And finally, if I didn't find the position, I'm going to return the final result. So let me just use the result equal to 1 here, and the result equal to I plus 1. If I didn't find anything, so the result is going to equal to n. It means from the right side it's going to be nothing. Now let me just run it to check. As you can see, it works. Now let me submit it. As you can see, it works and it's pretty fast. And the idea is just everything about the property of preorder traversal. If it is preorder traversal, the first node always going to be the root node. And then from here, from the second node, from the second value, we can always find a range. This is going to be the left subtree, and after the left subtree, it's going to always be the right subtree, because this is just the property of the preorder traversal. We're going to first traverse the root node, and then we're going to traverse the left. After finish the left, we're going to traverse the right. So according to the property of the preorder traversal, we're going to write a DFS to solve the problem. And the difficult part maybe we're going to need to find the index. And for finding the index, we need to I use another check function to find the index. I think that's all for 8, and the time complexity is O(n), and the space complexity is O(n) as well. I think that's all for 8. Thank you for watching. See you next time.